Hey everybody, this short video is about air traffic control and specifically how it is coordinated. So here is a screenshot from NASA of this thing called Smart Skies. At 11:50 a.m. Eastern Time, there's some 4,700 planes. In our class, we've looked at a different website that shows basically the same things. And by the way, this isn't even all of the aircraft in the sky. I believe these are just most of the commercial aircraft. But you can see how busy it is. And it's a big job to take care of it. So the National Airspace, or NAS, is composed of a lot of different things. So it has airspace, which we'll talk a little bit about, airports, aircraft pilots, navigation facilities and equipment, and so on, and a lot of other things. So let's take a look, a little bit closer look at what the FAA does for air traffic control. So, or ATC. So ATC, or the Air Traffic Control System, is a national system that's controlled by the FAA, which is the Federal Aviation Administration. So its purpose is to kind of coordinate all the traffic of aircraft and make sure everything is safe and keep safe distances, keep safe speeds. If you look at some of the sectional charts that we have looked at, and the SkyVector site, it will show you that you can't just fly around between airports. I mean, I guess you could, and some do, but generally there are accepted highways, if you will, in the sky. Well, how did air traffic control start? We kind of talked a little bit about this when we started talking about navigation, and we said that the early aviators, and I'm not sure what kind of airplane this is. It's a biplane, doesn't matter what model, but they looked for things on the ground. Remember, these guys didn't fly 500 miles an hour from New York to Los Angeles. They might have flown from state to state, and they had visual references. Maybe it was, a neighbor's barn or a silo or some other big building or a highway or a railroad or something. Then in the 20s, airports started using things called flagmen. And so they would literally wave flags in airplanes. So again, this was a visual reference, but these were airports that had signals to tell the airplane if he was too high or too low, if he was too shallow coming in. And then finally, in 1926, the Air Commerce Act established some more rules because things were getting really crazy. And then finally, also in 1958, it got a lot more serious because after World War II and in the 50s, this is when you started to see transatlantic flights, transcontinental flights, jet aircraft, not only were for the military, but they started becoming more popular with commercial flights. And so there needed to be more of a more controlled system, and someone had to control it. This is a little bit of an eyesore, and it's something that all pilots know. And there are different classes of airspace. So there's A through G, and it kind of looks like an upside down cake, really, if you will, like a tiered cake. So if you think of a wedding cake, it kind of looks like that. And so with these different tiers, you can see like a non-towered airport. You can go up to 14,500 feet. MSL is above sea level, right? So Class A airspace is above that. It's from 600 to 18,000. You can see how Class B airspace, it goes up to a certain level, and then it gets wider, and it goes up and it gets wider. And so this is the diameter at an airport. And you can see how this works in some of the sectional charts. I won't go through all these, but if you are a pilot, you have to take a test and know what all these are for. And here's just kind of a little bit different look. This last picture talks about some of the airways or jet routes that I'd mentioned before. So these are federal airways noted by these blue lines, typically between VORs, or they don't have to be between VORs, but that's typically what they are. So when you approach an airport, so part of air traffic control is getting you from one point to another. But then once you get to your final destination, there are also some very specific rules on how you have to fly, right? So it's probably better to take a look at this diagram. And so if we were to take off here in the lower left, and we know which direction the wind is coming from by looking at the diagram. So I'm not sure if you can read it on the video. So the wind is blowing from the right to the left on your screen. So we're going to take off going this way, and we're going to depart. When we approach an airport, we might approach the runway a couple of different ways. They might give us a direct approach where we can just fly straight in and land on the runway. That's typically not what happens at O'Hare and Midway. There is a pattern that you have to fly in. You might loiter is a term that's used in aerospace engineering and the aviation industry. Loitering means you're flying a big loop and you're waiting to land. There could be some weather that you're waiting for. Here in the Midwest we have a lot of thunderstorms. You might be waiting for a thunderstorm to pass through. But I might come in from the south. Let's say this runway runs east to west. I might come in from the south, and I'm going to go, this is called the crosswind leg right here. Downwind is parallel to the runway, and I'm flying with the wind. It's also common to enter, for an airplane to enter this landing pattern on the downwind leg. It can enter it on any of these legs. So we go downwind, so we go crosswind, downwind, which is parallel, and this is typically out several miles from the actual airport. And then it's also this base leg, so we turn base and turn final. And you'll hear, if you ever put some earphones on and listen to air traffic control, you'll hear these terms. Downwind, turn base, and turn final. Final means final approach. And that is how it's done when you approach an airport. So it's a little bit like a racetrack. It's not quite an oval, but the spacing here is really important. So there are some different rules to fly by. VFR and IFR. You'll hear those terms. There are probably some terms that you should know. VFR is just visual flight rules. I have to be able to see the airport. I have to be able to see around me. And then IFR is instrument flight rules. Pilots have different ratings based on their skills and the tests that they have taken. And then the standards that we developed here have been used throughout the world. So, for example, I think we talked about this in one of our Monday videos, that the standard language for air traffic control all over the world is English, which can be kind of challenging because, we don't think we have accents here, but other countries think we have accents. So learning to listen carefully, and plus the radio adds another variable to communication. So one thing that's kind of interesting, Chicago is a very, O'Hare especially, and Chicago in general has very busy air traffic, but the air traffic controllers don't actually sit at O'Hare. They actually sit in Aurora, and you can drive by their building. It's not far from school, and they don't actually see the airplanes. They see a visual representation on their screen, and they have all kinds of different screens. They don't always use radar. Aircraft a lot of times will transmit what their speed and altitude is. And in fact, you can see that if you go to one of the websites that we talked about in our class. So an air traffic control center has to coordinate all that movement. They're really kind of like a traffic cop. Well, what's next? There's a thing called Next Gen, which is going to hopefully make things safer. And there's GPS that's used a lot. Things are a lot safer now than they used to be. But that's it.